Hello, welcome to another Blender Sushi live noting series. Tonight I'll try to explore both animation nodes and Sverchok. They both is add-on made for Blender, and they both have kind of different ways of workflow. Um, while with Sverchok, you can go inside the elements quite easily. With animation nodes, you kind of work more in the object level. With Sverchok, you can easily go inside the components compared to animation nodes. However, if they they both is a fantastic add-on in Blender, really. Yeah, so maybe just relax tonight. I will be touching a little bit about matrix and maybe vector, and let's see how they both compare with each other. This is gonna be pretty basic, but it's interesting anyway. So make sure you have the add-on installed. So if you have animation nodes, see I got a tick and Sverchok. There you go. And they both. We just go to compositing layout, and then Sverchok, that's the Sverchok icon right there, and this is animation nodes. With animation nodes, I usually think in the object level. However, as we know, we can also work, play around with the components inside animation nodes. But Sverchok is much easier somewhat. So let's say with animation nodes, we can, let me demo something. There is a node, for example, called get selected objects, and this node is kind of monitoring whatever you have selected or active, and it can do something to the objects, kind of maybe like move the objects around. So selected objects, like with animation nodes, you always need to use like loop, and say I want to move this object around. I can loop this with this node selected. I can tap W and then loop through selected objects. Now inside the loop, I can make these objects kind of move around using object transform output. Let's say, okay, if I pipe in the objects like that, and with the location, I can use the vector wiggle frame, and I can plug this in there, vector, and the seed. Usually we plug in the index. So depending on how many objects you have in the scene, how many you are selected, we're gonna see how you can see the object is moving by itself. It's kind of like possessed. And we can select the light as well, select the camera. They're all moving because we have this thing get selected objects, and it's kind of monitoring the objects that we are selected and kind of moving them around. We can also perhaps wiggle it. Okay, use wiggle. Sorry, not vector wiggle. Euler wiggle. Do the same thing. Frame to evolutions, and we need the rotations. This is probably the simplest example. Index. So speed. Increase the speed. Select more objects. Yeah, so moving objects around or organizing objects is really animation nodes kind of thing. Let's see if we want to arrange this guy in the grid, kind of like nicely in one line, we can use let's see, line mesh. So vertices, plug that in. Just going for index, plug the index in. So how many objects we have? So I just have 4 objects lining up like that. And see, can I? That's interesting. Anyhow, that's like animation nodes. If we switch to Sverchok, let me delete the animation nodes. Sverchok, create a new nodes tree. Let's say I want to deform this guy, like in the edit, in the component levels. I can use vector noise generator, analyze transform, vertex randomize input vertices. That's really cool. Randomize vertices, amplitude seed. First we need to get the objects, right? So we use the objects in, plug in the vertices. We need to select an object. I'll get that object. So we have one object selected, and now I will just use a viewer draw, and hopefully we can see the objects like that. So I wiggle the vector like that. And with Sverchok, we usually have this kind of like a viewer, and it's kind of like a ghost. I usually think of it like that, the ghost of this object, and it's kind of like a preview of it. If you're happy, then you can bake it, or you might wanna animate it. You can always bake it using the MDD and then bring it back using mesh cache. If you're happy, you bake it, and we have a new object like that. So Sverchok, when dealing with component levels, is a lot more efficient. And with Sverchok, we have a lot more generator, while with animation nodes we have probably only we have only line and grid. So we can generate mesh like that. So let me delete this Sverchok node first, and back to animation nodes with grid mesh. Okay, we want to output. If we want to output an object, we use the object output. It says we create a new object, target object, turn on mesh data, and we need to combine mesh data, and then we plugged it in. we actually have these points and we don't have the edges or the polygon face yet. I can plug in just the edge like that, so we have just a line kind of mesh with edges. And if you are using Blender for the first time, if you want to render it out, you can use something like maybe skin modifier, yeah, and then make it smaller like that. Control A. Or if you want a proper grid, you plug in the polygon indices like that. You don't need the edge, and you can adjust it. So that's animation nodes. It might be slower, just slightly slower compared to Sverchok. It's just a different way of thinking. And so back to Sverchok, you can do the same thing, but Sverchok has a lot more generators because Sverchok has been developed maybe longer, a little bit longer than animation nodes, and Sverchok has 3 or 4 developers like Nikita, Zefi, and Linus. Yeah. So let's like line, plane, N-gon, box. So with Sverchok you even have these box generators. Really cool. So if you want to output it, remember we just use the viewer draw and into vertices, edges, or polygon. So you have a real box, and if you want to move it around, you play around with the metric, matrix in, yeah, matrix in, and we need the location, vector in. Then we have the objects, but it's still a ghost. We cannot render it out. We need to bake it, and we have real objects. Yeah, so and you can adjust the diffusions, for example, and you can bake it, and you have the actual objects. This is really cool. And then even this is just a ghost object, you can of course vertex randomize input vertices. Let's plug that in and plug that in, and you can do something like that. And if you're happy, you bake it out. So goes, you like it and you bake it out, but then you don't always need to do that. There is another there's another node that you can use, and it's called the MK Viewer Bmesh MK2. So vertices and the faces, is it polygon, and the matrix. So this is actually a real object. You can render this out, and this is like real time. At the moment we are using Blender Render, it's the default. We can turn on the ambient occlusion, of course. You can, yeah, it's real time. You can see the effects, and let's have a look. If it's not updating, you might need to scrub the timeline, because in the past that's how usually you update Sverchok. But that's, yeah, really fast, really cool to generate mesh like that. And Sverchok has like heaps of nodes. Actually, it's maybe almost 100 nodes. Or let's see, with generator, what else? Circle. I wish that animation nodes has circle, but as you know, we can use a scripted node to do that. Hilbert image. Even there's this generative art. It's kind of like a structure scenes. There is another like a 3D program. It's an open source to generate like a fractal kind of structure, and this is kind of Sverchok version of that thing. And we can analyze objects, analyze, let's see, predicts normal. Oh, I like Sverchok how in Sverchok, let's say if I get rid of the randomize, bring it back, so we have this guy. In Sverchok we have like a index viewer index. I love this node. It's one of the first nodes in Sverchok. We could easily see the index of each vertices. Okay, at this moment the vertices is not displaying at the locations, probably because of the matrix. I believe we can use matrix apply. So with this guy apply to that, and this guy to apply to that, plug that in. That means not falling. Okay, maybe I need to plug that in there. Okay, it's working like that. Size division, maybe make it 4. See, we can see the index number of each vertices. I like that a lot because it's super useful if you're working in a node-based environment. You can also look at the index of phrases. Let's have a look. That's the index number of each phrase. It's very useful. With Sverchok, if you want to see the data being outputted from the node, you use the viewer text, and you plug that in, and then you click on the view, and you can go to the text editor. You will find this Sverchok viewer, and I just now I just outputted the list of all vertices being generated by this box. So it looks like this. While of course in animation nodes you can do the same. If I'm selecting this object being generated from Sverchok, and I will use mesh in. Oh no, wait. Back to animation nodes. I have to switch my brain. Let's get the mesh, object mesh data, get the object, vertex locations or the vertices, which one you like, and we just debug it. There's a debug drawer. There's also the debug loop or debug list. We can use debug list. So with animation nodes, we just plug in the data into this slot, click on there, and then animation nodes, we have this cool like a pie menu, and then we can see the data. This is super cool. You can actually have multiple, I believe. Debug list. It's a debug drawer. Debug drawer also give you that thing, kind of more like real time. And if you have both animation nodes and Sverchok, let's do this and switch to Sverchok. And if I modify the vector, you see it's updating live. It's updating live in the animation nodes, which is cool. Not live in Sverchok, but you can just click on that and it will update. In Sverchok, you can see it's there is this the text is really useful. I like how the developer really think about how the user can see the data really nicely as a list like this. It says there's 152 vertices, and that's the coordinates of each vertices in 3D. XY displayed as XYZ. Okay, so animation nodes can do the same thing, and they both are super useful like that. What's next? I can show you probably the scripted node. Okay, let's do that. Let's hide this. Just hide. Okay. Let's we don't need that. We don't need that. Let's delete this guy as well. Okay, we'll be back with an empty 3D scene. Sverchok has a really super cool scripted node, and also this there's another script node number 2. It can create grid, line, petal. Petal is classic example in Sverchok. Let's have a look. What's the difference between those two? So just like in animation nodes, you have a script node that looks like this, where you can create input and output variable and then write your own script. Sverchok has similar thing. With Sverchok, let's say I really like the flower petal scene or petal sign or the flower example. Yeah, I think this is the petal sign. I select that example script, and then we're gonna load it, and by clicking this icon, now it's in the text and petal sign, this guy. So I'll turn on the line number and the Python. And as you already know, Blender is Python based program. So animation nodes is using Python, Sverchok is also using Python, and Python is really super kind of user-friendly programming language. If you're not a programmer like me, like few years back, before I ever touched programming, it's kind of scary to look at this, but Python is really so user-friendly. And then if you brave yourself to learn programming, understand the concept, slowly you'll fall in love with a Python language. It's super easy to read, and if you're working with a 3D program like that uses Python, like Blender especially is fully Python, you will find it super useful. Okay, so back to Sverchok. So we have the petal sign Python script. This is like a specific Sverchok script, but you can easily convert this script into, so we can use it inside animation node. I tried it last night, and it works. It works beautifully. So this is supposed to create flowers. So it has this like function definitions in. First, it's loading this module. It's needed for the script. So it defining functions, and we are using Sverchok main, and this is the input variables. So let's just load it, and we can see now it becomes a node. A node has input and output. It will generate this kind of flower pattern, and so it has number of petals and then hertz per petal. I don't know what it is, but we can have a look. Let's just plug it in, plug in the edges maybe, and so we have a flower generators basically. So we can increase the petal, we can increase the, what is this? Okay, that's the vertices, number of vertices, and then we have these options to adjust the profile radius and then the amplitude. This is kind of, the petal sign is similar to gear I don't know if we have like a gear generator in Sverchok, but someone can make that. Maybe you make it. And we have beam sphere. Okay, back to the functions. So this is kind of Sverchok specific. You have the in socket defining the what do you call this? The slots, and then we have this variable pedal, and this is the actual functions to make the flower, and we have the output sockets, and it will generate this flower pattern. I believe there's also scripted node number 2, and I think this might be doing the same thing. So we're gonna load it. It's not loading. Oh, it's there. Sorry. Pedal. Let's have a look. Pedal sign, and then pedal. Pedal.py. So this one is using class, and there's this input, output. It's probably more elegant. Return edges. I believe it's doing the same thing. Let's do it. Let's have a look. Edges. Okay. Because I have the same name. I should be using a different name. So flower generator. Let's just delete this, we don't need it. Delete this and then see and regenerate the flower. Okay, we have this guy, and there is what's next. I can show you. Probably I'll be touching, like I said, I will be touching a little bit about the vector and matrix, even though I won't explain what a vector or matrix is. Matrix is made of several vectors. That's what I could say. And usually matrix is related to the transform of objects. Each object in the 3D scenes will have its own matrix, and it consists of the vector position or translation, and then vector scale and vector rotations. So if we have, for example, okay, let's delete this pedal sign and let's choose a generator. Sphere, maybe use box. Box is the simplest. N-gon, no, maybe use box. Use box. Let's have a look at random vector. If we try random vector and plug in the random numbers it's generating. Okay. So it's generating all these points. This is actually a real objects already. And then what can we do with it? So that's just a bunch of points, right? As you can see it. But what's interesting about Sverchok and this random vector is we can use this random vector position as kind of a way to instance objects on those points. And if actually one thing I want to kind of point it out, with Sverchok you don't see looping happening. Unlike animation nodes, you almost always loop things to get the animation nodes to do something. In order for it to work, you need to loop. For example, with animation nodes, if you want to have like a random vector, like this guy have a count, and you can quickly use the value right away. With animation node, you kind of need to loop it. So it's kind of this is just will output a single value. If you debug it, see, it's only outputting a single value. What if you want a multiple value? For example, you use loop for that. Loop input, and we're gonna use the new generator output, and we know we're gonna output vector list, and we know that this guy needs to be inside the loop like that. And how many vector are we outputting? Only once we create a loop like this. So as you know, I did this like many times. We use the invoke sub program, and this is the loop. And let's say we want a 10 different random value. Now if we have a look at the output, whoops, sorry, let's debug it, and that's what we have. 10 different value at the moment. Okay, be careful, this is a random value, but they are all the same. Why? That's because I forgot to plug in the index into the seed. Now it's actually generating a random value, just like what Sverchok does right here. Let's say if I just say 10, the value of 10 different objects, like that. Okay, it's doing the same thing. With Sverchok, now if I want to use this random value to generate kind of like a copy instance, I will do it like this. Let's cut this. I'll create a matrix in. So there are some different terminology between Sverchok and animation nodes, but they are actually similar. So it's a generate a random vector value, like 10 different random values. So I'll plug this into the location, and I will use this box, and we'll generate it. Hopefully it works. Yes, it works. Now if I want to scale it, actually random vector math. Do we have maybe scalar, noise scalar, multiply scalar? This is probably correct. And then I use like a float value. Okay, that's kind of like a scale, vector scaling. And of course I can randomize the seed. That's how you do it in Sverchok. So it's always, so you have the original objects, and then you plug in a vector random value into the matrix, and then you generate this. Do we have Euler, matrix Euler? You can definitely use that. Random rotations, we don't have random rotations. Let's see if I create another random vector, and then I plug in the rotation. It's not doing anything. Kind of forgot how to do it in Sverchok. Do we have rotation, angle, vertices? Forget it for now. We're gonna come back to that. Oh, okay, there's actually angle. Probably angle is what we want. Okay, so we need a random vector. Plug it into rotations. it might be defining the axis, and then we need to have the angle float, plug it in. Okay, it's not okay, it's doing something, so that's doing something with, oops, I just generate like a 340 different objects, and Sverchok is frozen. I think Blender might be crashed. Maybe I generate like thousands, it's not displaying. So I'll just probably kill Blender for squid. Don't worry. Let's just restart Blender. If you're using Mac and you work with a Sverchok and animation node, sometimes you want to, instead of running the Blender app like this, you go inside, show package contents, and then inside it, under Mac OS, you start from here, so you have like a terminal. This displays a lot of useful information that's normally you don't get if you don't have the terminal running Blender. So it's loading Blender. Let's wait. Okay, still recording. Okay, we just hide it. Back to Blender. Now back to compositing layout. We have seen how Sverchok kind of duplicating and instancing objects. Let's see how we do it in animation nodes. This is actually, you probably already know how to do this, but anyway, I'll do it again just to show you. In animation nodes, we need to have object instancer. We don't know how many instances we have yet, and we're gonna need to loop the instances, right? Loop through objects. And since we don't have box generator inside animation nodes yet, so we need to use objects that's already in the 3D space, in the 3D view. We don't know how many instances to create yet, but we could load that object, and maybe we're gonna create 10. Now it's already creating like 10 different objects here, but they are all in the same position. And how do we reposition the objects? We're gonna use the vector, the object transform output, and we're gonna tell the loop, okay, for each and every object instance with the position, we're gonna randomize the positions by using random vector like that, and we plug it in the index into the seed, and then we plug in the vector, and now we have exactly the same thing, just like Sverchok. That's the original object, so we can hide this guy, but that's the instance copy that we have. And in order to hide the lines here, we go to here, hide relationship, okay, like that. So different way of thinking, but they both is pretty unique. They both are interesting, I guess. And so what else? Of course, we can randomize the rotation. And in animation nodes, we have Euler, random Euler, plug that in, and plug that in. Yay, random Euler. And You can play with the seed. If you want to think kind of this is actually very, if you want to think like a Sverchok inside animation nodes, this is actually, you can actually use the matrix kind of in like in the Sverchok. When I first used Sverchok a few years ago, it's kind of shocking for me to like, let me generate like something real quick inside Sverchok. Generator, I'll use the sphere now. Sphere, maybe reduce this to 8 by 8, and I know I'm gonna create like a bunch of sphere draw. This is a sphere, plug it in, polygon. So that's a Sverchok ghost object. Hide the vertices, and then it's kind of shocking for me to see this the first time in Sverchok. Oh, okay, so we need matrix in. So, and then random vector, of course, give me that. Just like before. Just need to be careful I don't generate like too many. That's kind of surprising for me. I never used something like this before. Matrix in, and the matrix need a vector, and then it can do that. That's kind of moment of revelations, kind of. You can do the same thing inside animation nodes actually. So we are thinking not using object transform. Let me make this full screen. So you're not thinking object transform output is kind of more friendly for artists that's using normal environment. So we understand that if we have an object in the 3D scenes, we know that we can adjust the location, rotations, and it's we call that object transformation. But you don't usually think about the matrix. But inside animation nodes, you can think about it kind of the same thing. There's a matrix output, object matrix output, and now we have something that's totally scary. It says object matrix output. What is that, you know? Let me delete all this, and then okay, it's leave. We have all this object instance left behind, but each and every objects here can be controlled using the matrix as well. So it's still the same. So we generate some instance objects, replicator here, 15 objects. It goes inside the loop. Inside the loop, then we can tell animation nodes, okay, these objects by default it goes back to 0, 0, 0. With these objects, please do something, right? Please do some things. And we can use matrix, combine matrix, I believe. Combine matrix. Not combine matrix, there's another thing. So we look at the matrix menu, we have translation, rotation, scale, translation, rotation, scale. There's a matrix combine, and there's a compose matrix, that's the simplest. Compose matrix, we plug it in. Now we can control the objects, of course, but we know there are 15 objects. They are all sitting on the same spot, and we don't want that. We of course want to have like a vector, and let's do that real quick. Vector, let's say a random vector, and then we can plug in the seed, and then we plug in the vector there, and then they're all this is now kind of very Sverchok kind of thing. They're all, it's now very similar to Sverchok kind of. So while in Sverchok you don't have the loop, it's kind of like hidden, it's in the background. With animation nodes, it displays the loop for you. So we have 15 objects goes inside here, and then the loop will know that, oh, okay, there are 15 objects, and do 15 times iteration for each object, and then place each object in the position based on this vector. So it's actually now it's actually generating 15 different values here, random vector. If you don't believe me, I will debug the number. Instead of using this debug, use a debug loop. And let's have a look, and then click there, and then click there. We have 15 random number being generated automatically. This is like super cool. So you don't need to create a new generator output. It will work for you right away. So this is very Sverchok like. I like it. I like it so much like this. Let's see what else. We could actually generate the random list of random vectors outside and then plug that in. I'll give you example real quick. So instead of putting the random vector here, let's say if we want to use line mesh, we know that line mesh will generate like a position, point position. So it will, let's just have a look. See, you see here is this node alone is generating vertices. And how many vertices? 2 vertices. Yeah. Let's say because we have 15 instances, we want to have 15 points here, and we want to plug it into and put it into the loop. We don't have the slot yet, so we're gonna create it. New iterator. So it's got. Let's create one. It's gonna be vector list because it's blue color. It's sometimes it says vertices, sometimes it's supposed to be a vector. It's 3 values anyway. So vertices goes in, and then we can plug this in. So we have objects in a kind of like line arrangement. It's going up like that. How many objects it's generating? Did I make a mistake? Let's have a look. No, it's correct. It's 15 objects. Maybe quite a lot, but it's okay. And it's going up in the z-axis. We can tell it, okay, go sideways in the x-axis. Okay, let's do that real quick. So then we have these 15 objects. I'll save this real quick. This is AN Sverchok Matrix 001. Save. We have these 15 objects. We can maybe for now just let's say 8. Tell it to have 8. If you have lower, so it doesn't matter. It's kind of like, okay, it's iterating. It knows we only have 5 values, so it will put 5. There are actually probably 8 cube here somewhere, so we have, so to make sure we have the same number of input going in. But the loop will try its best to compromise that. So we got a loop, and we have these translations. What else I want to show you? Probably I'll give it some this cube some color so we understand what's happening. So this is the master objects, right? The cube being replicated. I'll give it a material real quick. So this is a material already. It has the default material. I'll make it a turn on the object color. So for this object, we can colorize it and we can see it in the scene, in the 3D scene. I want to colorize this box as well. So you have learned how to do that. Let me turn on copy full objects. Now, okay. It can take color now. For each object, I can do the, let me think, object color. No, this is an attribute, object attribute output. So for each and every object, we're gonna change the object color attribute, and then it needs to be let's see, 4 value float list of float list, create a float list, 4 number, plug that in. It's actually working now. I just need to, okay, it's all red, yellow, and I'll create a random value, random vector. Random vector goes from -1 to 1, but for color we need number between 0 and 1. I believe if we normalize the vector, we can have it. If you don't believe me, let's have a look. There's a debug drawer. It's debug drawer. Have a look. Oh, cannot see it. It's just a debug loop. Plug it in. Have a look. 8 different random vector. It goes from between -1 and 1. If we normalize it, normalize vector, now the value goes, okay, it didn't, the number is still between -1 and 1, so I lied. Probably we need to use some remap. So I'm going to separate the vector. Vector goes in, now become 3 separate value. And now we can remap it, map, range. Make sure the value goes in. Originally it's from between -1 and 1, now it should be between 0 and 1. Plug that in. So it's working. Let's do the same for the Y, which is for the correspond to the green value, and then one more for the blue. RGB random value scale. You can scale it. Interesting. You can randomize the value. Kind of like it, how it's kind of desaturate like this. It's kind of beautiful. Let's save this. So we have 1, 2, 3, 4, 5. We have 8 different cubes, 8 different boxes here with all random color, and we can of course adjust the gap. And something I want to show you is in regards of the list in animation nodes. We have some operations that's dealing with list. I don't touch this quite often, but of course I use list all the time, and we can shift it, we can slice it, we can shuffle it. Probably I'll start with shift. So like I said, this line mesh node is generating 8 different values, right? It's a 8 elements in the list that we can, and we can actually plug it in into shift list like that. Nothing changed, but if you do that, you can see that the list is actually offsetting. If you look at this pink color box, and I'm increasing, now it's actually shifting the list. You can actually see this real quick using the debug drawer. And I'm shifting the value. Plug this in. So the value is shifting. That's something you need to know. It's really super useful for that reason. Next, I want to show you how you can kind of like replicate the array modifier inside animation nodes using this like a matrix and vector. Okay, we have this kind of complex thing happening. Maybe we don't need to colorize things for now. I'll cut it. Let me cut the random from that, so it's we are not using this for now. We don't need the shift list. Just put that in. This matrix thing is super useful actually. You can do something like this, matrix position, see matrix combine or combine matrices. Let's say we have a matrix position, it's called matrix translate matrix. Plug it in, it automatically creates this create matrix list node, and you can have multiple and mix a lot of bunch of matrix together. Let's see what it does. See, it's translating that object, and then next, if you use a matrix rotation or rotation matrix, plug it in, it rotates the object like that, maybe in the Z. So that's actually kind of classic example of how you mix the matrix to get that kind of look. And what's interesting is now that we have, let's say if we have 8 different objects, let's say if we have 10 different objects, 10 objects, and we want to create kind of like a circular thing, I believe we can use the index. Okay, it's actually accepting Euler, so we need to have a Euler convert matrix Euler. Now I have to think convert angle, degree to radian. It should be accepting degree, and then we need to use math. It's just a little bit slightly more complex, but it's not really, it's still super basic. We can have that thing happening. We have that 10 different objects, so 360 divided by 10 is 36. 36. Rotate the objects 36 degree like that. And let me save this real quick. File, save as. Okay, we still have the color. We can still have the random color now. Let's plug it in. Plug the index into the seed. Yep. Okay, it's working. And then what else? Matrix math. One more thing, matrix math. If we multiply matrix together, we actually have something that's like a parenting. Let's see this. Now we can translate. Rotation, let's see what rotation gives us. Okay, it's rotating each and every object. This is not the effect I really want. There is another node, matrix change pivot. That's right, change pivot. Transformation matrix, pivot matrix parent. Let's try this. Plug this in, plug this in, plug that in. Let's see what we have now. Okay, that's interesting, but not what I really want. Pivot location didn't do anything. Rotation, oh, okay, still not what I want. There is this X line, Z line, center and rotation. Let's have a look. Center and rotation. Center, rotation, rotations. Okay, not what I want. X line, Z line, X line, Z start. Okay, not what I want either. Probably the pivot matrix. Okay, well, that's probably not what I want either. Anyhow, we have this happening, and let's see if I can. So we have vertices goes in there. Vector. Do we really need vector list? No, we don't have this anymore. We don't need this anymore. We can delete it. And everything's still working. The math, okay, 36. Sweet, 36. In order to get that 36, I was dividing 360 divided by 10. We can actually do that math thing. Divide. So it's 360 divided by the total number of instances, and we can use iterations for that. And we're gonna have 36 here, and just plug that in. So that will take care of the number. So we can have more or less, and it will work. And so let me save again. I will show you another thing in animation node. So we have group node. With group node here, we actually cannot put the object instancer inside the group. If you try, it will complain. Let me try real quick. So it's give an error, so you can't do this. The object instancer is actually a special node that, and it needs to be outside, kind of always outside of the loop. But I believe we can see. That's my group. That's the source, loop input, output node, source, parameter. Let's see what we need to control. Suppose we're gonna have this random color parameter. Oh, it's complaining as well, so we can't do that because that's not how you do it. Let's delete this. Objects is outside. Output node need parameter. The objects list. Okay, let me try this. Now it's actually that's correct. So the object list should go in there. What else can we control? Okay, the translation. I'll plug into the group. So we can't do that because we need to kind of pipe it into here. That's the translation, and we can pipe into the group. What else? Color. Okay. Scale the node seed. Maybe that's enough for now. So here are the objects and the translation, and it's become, let's call this my circle. And then next we create another my circle group like that. You're probably thinking, what is this guy doing? You will soon find out. So this is where where magic will happen. With group with a group node, we kind of grouping all these operations and just simplified it into a node. So let's say I have this cube. Let's see if it's working. So I have this cube working like that, and then suppose I have another object like icosphere like that, and for the icosphere I'll give it a material, same material like as the cube, and then I'll load the icosphere here and then plug this into that, and now we have yet another kind of formation like that. And then we can have something like that, maybe increase it, and then we have another thing, torus, cylinder, cone, let's say torus, and apply material and then load it into here and plug this into that thing and then adjust it like that. So I found that really cool. So now we can actually do something more with this. So it's object instancer goes into the group node, and then what if we want to do more with the group? So we need to output the group. So let's see if we can do that. I'll click on the output node, and then okay, it's gonna return the object. Let's try that. Plug this into that object. It's giving me error. So that's not how you do it. You actually need to, okay, this is the loop, this is the loop. Probably use objects as output, yes. And then back to the group, input, and then output, return the object list. Now we have object list output for each and every object. Let me try for the torus. I'm gonna loop it again. So you're probably thinking, wow, let's do object transform. Let's see if this is actually working. Let's see if this is working for each and every object. It actually goes back to center. That's not what I want. Let's try matrix output for every object. That's also going back to 0, 0, 0. But that's compose a matrix real quick. Sometimes you just play around with the node and then test it, you know. Okay, that's kind of more like it, although it's weird. Parent inverse local world basis. It's not giving what I want. I actually want to rotate the whole thing. So for that I might need to ask this animation nodes developer how to do that. But let's see, for each and every object, maybe compose the matrix. Maybe I can kind of matrix decompose matrix for each object. I will use the translation. I can still scale it. Rotation, what? Okay, rotation is doing that. Translation is doing funny thing. Object world translations. Probably because of this basis thing. Maybe we can use the vector value. Vector can be confusing. Now it's kind of doing what I want. So we kind of decompose the matrix and then using this to do the translations. That's kind of what I want. And then maybe I want to also rotate it. And then I will use the Euler math probably. And then using the original rotations, plug that in and plug that in. And then maybe I can rotate. No, I still I was actually expecting this guy to rotate. Rotate is kind of more complicated. I really need to ask the animation nodes developers about this, how to rotate the whole thing. Scale, let's make it goes back to normal, original. Local, is local doing it? No, local is not doing it either. So it's not in the Euler. Anyhow, we have this. And then what else we can do? Translation for each. If we don't have this, goes back to normal. Matrix, do we have kind of matrix compose? See what else, something else we can do. Matrix, mixed matrix, or let's see. Matrix combine, and then we have this. Okay, goes back to original, and then let's see if we just give it a try. Okay, go ahead. Okay, that's kind of doing it as well, kind of what I want. Funny thing. And then we have this. Okay, what if we want a translation for each object? Let's try matrix decompose matrix. Plug that in. Okay, that's not good. Matrix translations. Vector angle, vector math. That's not what I want either. Index iterations, object, matrix decompose. Matrix input for each and every objects, world, translation, and then compose matrix. Once more, translation goes into translation. And what if we use the vector math? What if we randomize it? Random vector. Okay, that's randomizing it. Scale. Okay, what if instead of random, if we use the normal direction to rotation? That's useful. Let's see, translation goes into direction. Euler rotations. Translation, rotation, scale. That's for the rotations. Okay, that's what we got. translations. Let's see if I could subtract this guy and this guy. Subtract and plug this in, and then we'll multiply, scale. It's doing nothing. Oh guys, I guess don't worry about it. For now, this is all we got. And we have seen how the matrix and the vector, the basic vector and matrix you can use in animation nodes. I guess it was quite a long day, but play around with the number and see if you can make each and every object goes like up and down like this, and make kind of wave pattern. You know how you can rotate each and every object. Probably you can offset it, delay offset it, and all sort of things. This is kind of how you create the mandala setup that I think I demo on the previous videos. So that's Sverchok and animation nodes kind of comparison, and you have seen how you can use a script node in Sverchok and all kind of stuff. The script node in Sverchok can easily be translated into animation nodes as well, and how each can generate mesh. How Sverchok use a lot of listing, while with animation nodes you will work inside the loop and more in the object level. So in Sverchok, of course, you can create something like this as well. It might be slightly easier, I don't know, but yeah, both can do the same thing. And then anyhow, give it a go, and maybe I'll cover more intermediate level technical stuff of both animation nodes and Sverchok next time. Hopefully you enjoyed this video, and I'll